This is Dr. D. Khalandar Basha, working as Associate Professor in the Department of ECE, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today I am going to discuss the minimum mode and maximum mode of 8086 processor and its timing diagrams for both read cycle and write cycle. The slides are prepared by referring the textbook Advanced Microprocessors and Peripherals, authors K.M. Budchandi and IARE, publication McGraw-Hill publication. The 8086 is operated in minimum mode by strapping its MN by MX bar pin to logic 1, that is connecting to VDD. If MN by MX bar is connected to ground, that is at logic 0, then the processor is in maximum mode. In the minimum mode, all the control signals are generated by 8086 itself. There is a single microprocessor in the minimum mode system, whereas in maximum mode, we are going to have multiple processors, main 8086 processor along with the co-processors. The various blocks in the system are latches, transceivers, clock generators, memory and I/O devices. The latches are used for separating the valid address from the multiplexed address, and the data signals are controlled by the ALE signal, where ALE stands for Address Latch Enabled Signal, which is generated by 8086 processor. The ALE signal separates the valid data from the time multiplexed address and data lines. The block diagram for minimum mode of 8086 is shown in figure 1. So here, the 8086 processor MN by MX bar is connected to VCC, which is to make the processor to be operated in minimum mode. Here we have a demultiplexer, which is for generating the various control signals for read and write operations for memory and I/O devices by taking the inputs M by I/O bar, read bar and write bar. By making use of these three signals, it is going to generate the four control signals are required for read and write for memory and I/O. MRD bar, which is for memory read operation. MWR, it is for memory write operation. I/O read, that is for I/O read operation. I/O write, it is for write operation. So here, the M by I/O bar and read bar, write bar. By making use of these three signals, we are going to generate few control signals. So whenever this M by I/O bar is 0, it is corresponding to I/O operation. So for read operation, we have to make read bar is equivalent to 0, write bar is equivalent to 1. Then it indicates it is I/O read operation. If M by I/O bar is equivalent to 0, read bar is equivalent to 0 and read bar is equivalent to 1 and write bar is equivalent to 0, it is for I/O write operation. If M by I/O bar is 0, these both cannot be at 0. If the combination is 0, 1, 1, then it indicates neither read or write with respect to I/O devices. Similarly, for memory operations, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1 combination will see. As read bar, write bar is equivalent to 0, both read and write is not permissible. So this combination is not applicable. 1, 0, 1, that is, it is memory operation, read operation. So it is memory read operation. 1, 1, 0, it is for memory write operation. 1, 1, 1, it is neither memory read operation nor write operation. Right. So this logic will be generated by using the demultiplexer signal. Next, here we have a latches. These latches will be depends upon how many address lines we are having. As it is consist of 8086 processor is consist of 20 address lines, we are going to have a series of 20 latches in parallel. The input for the latches are AD0 to A15, A16 to A19. When ALE signal is equivalent to 1, When ALE signal is equivalent to 1, the latches will be transparent and this address and data will be passed to A0 to A19 address lines. These address lines are used for selecting the RAM and ROM apart from the IO. Next, when ALE signal is equivalent to 0, when ALE signal is equivalent to 0, the latches will not be transparent. So whatever the previous output is there, the address information will be reside in the address information. Now the data will be passed to the transceiver. This transceiver, the data will be given to the memory or IO devices, or from the memory or IO devices will be depends upon a D by DTR. DT by R bar, which is data transmit or receive. When D by R bar is equivalent to 0, it indicates receive. That means the operation which it is going to be performed is a read operation. When dt by r bar is equivalent to 1, that is data transmission, in that case the write operation will be performed. The direction of the transceiver for the data bus, as this is a bidirectional data bus, the direction of the data bus will be depends upon dt by r bar. If dt by r bar is equivalent to read operation, so this IO device or memory will be passed this information to the processor. If d by tr is equivalent to 1, then from the processor the data will be sent to memories or IO blocks. Next, this one is clock generation, which are needed for the required clock pulses for the processor to be operated at a particular speed, that will be generated by the clock generator. Next, for the RAM and ROM blocks, we are going to have even address bank as well as odd address banks. The corresponding select lines are CS0. It is for enabling the odd address of the RAM. CSE bar, it is for enabling the even address bank of RAM. This CS0, which is connected to ROM, it is for enabling the odd address bank of ROM. The CSE bar, which is for enabling the even address bank of ROM block. For IO operations, we are going to have IO read and IO write operations. What are the control signals which are generated for related to memory, that will be applied for ROM and RAM. For RAM, we are having both read and write permissions. So memory read is given as one input, memory write is given as another input. Whereas for ROM, we have only read permissions, so only memory read is given. Whereas for IO devices, we will apply both IO read operation as well as IO write operations. So these are the various functional blocks we are having inside of the minimum mode for 8086 processor. When the processor is in minimum mode, only one processor will exist at any point, that is 8086 single processor will be there. The transceiver are the bidirectional buffers and control the direction of the data bus by dt by r bar signal, that is from the processor or to the processor. The clock generator generates the clock from the crystal oscillator used for timing reference for the system. The working of minimum mode are described using the timing diagrams for both a read cycle and write cycle. The opcode fetch and read cycle are similar, hence the timing diagrams have two parts. One is a read cycle, another one is a write cycle. The BH bar A0 signals are used to select the byte or word of memory or IO to be read or to be write. When BH bar and A0 signals, when these two signals are 0, 0, then the data we are taking is 16-bit size. When BH bar is equivalent to 0, A0 is equivalent to 1, the size of the data is 8-bit. And it is corresponding to the upper 8 bits. When it is 1, 0, it is also corresponding to 8-bit operation from the even address bank. 1, 1 is not used. The M by IO bar, read bar and write bar signals indicates the type of data transfer as shown in the figure table 1. The table 1 describes the type of data transfer. Whenever M by IO bar and read bar and DEN bar are equivalent to this will take us right bar. Whenever m by IO bar is 0, these are corresponding to IO operation. M by IO bar is 1, these two are corresponding to memory operations. 0, that is memory read, write 0, that is memory write. These two are for memory. Read bar is equivalent to 0, that means read operation. Write bar is equivalent to 0, it is write operation. The read cycle in minimum mode is shown in figure 2. The read cycle begin in T1 with assertion of address latch enable ALE and M by IO bar. During the negative edge of T1, the valid address is latched onto the local bus. At T2, the address is removed from the bus and sent to the output. The bus is tristated. The read signal is activated in T2. The valid data is available on the data bus. The read signal is inactivated. The address device will tristate its bus drivers. The figure 2 will show the read cycle of 8086 minimum mode. Here the clock pulses we are taking for 4 clock pulses. One mission cycle is consist of 4 clock pulses. If the IO device or memory is taking more time than the 4 clock pulses, then wait clock pulses will be inserted between T3 and T4. The number of wait clock pulses, it depends upon how much time it is required for responding from the slow response devices. So the number of wait clock pulses can be multiple also, but always they will be inserted between T3 and T4. During T1, the ALE signal will be 1. From T2 to T4, the ALE signal will be 0. When ALE signal is 1, that is during T1, the address and status lines will give the address information on A19 to A16. The rest of the time, this will give the status information. However, the status information is not required for the minimum mode. From the lines AD15 to AD0, during T1 cycle, when ALE is equivalent to 1, these address and data lines will pass the address information, that is from A0 to A16. Once ALE signal goes to 0, then the data will be placed here. So now as it is a read cycle, the data will be received from the memory blocks or IO blocks. As these two blocks are going to send this data, the speed of microprocessor and these peripherals may be same or it may have more time. Depending upon that, there will be a tristate which is bus reserved for a data in, which is for capturing of the data. Captured the data. Right. Now, the address information will be sent on the AD0 to AD line. The same address and data lines are used for accessing the data when you are reading. So as this address and data lines are using the same signals, for changing the direction of this address and data bus as output mode and input mode, we require some amount of time. That's why here we can see a little bit latency here. This is for changing the direction of bus. Change direction of bus. The valid data is present on these lines. Here, the data, once it is capturing, then we can enable the read signal. So till that point, the read signal will be inactive state. Once the data is arrived on the data bus, then the read signal will be goes to 0. After read signal is disabled, then the data which is present on the data bus can be tristated. So this is the minimum portion. We need to keep the valid data on the data bus. When the data is captured on the data bus, the DEN bar will be goes to 0. The next one is, as it is a read cycle, the data flow, it is from memory or IO device to the processor. So here, the direction of the data bus or the processor is taking the data, which is nothing but receiving mode. So the dt by r bar will be placed in 0 state throughout the read cycle. So this is the read cycle for both memory and IO devices in the minimum mode of 8086 processor. The fetch cycle also same as that of read cycle. The next one is a write timing diagram. The write cycle is shown in figure 3. In write cycle, begin in T1 with assertion of address latch enable, that is ALA signal, and M by IO bar signal corresponding to memory or IO operation. During the negative edge of T1, the valid address is latched on the local bus. At T2, after sending the address in T1, the processor sends the data to be returned to the address location corresponding to memory or IO device. The data remains on the bus till the middle of the T4 cycle. The write signal is activated in T2. The valid data is available on the data bus. Now we will see the timing diagram for write cycle in the minimum mode. For every mission cycle in 8086 processor, we require 4 clock pulses, that is T1 to T4. For slow response devices, we require more than this time. So wait clock pulses will be inserted between T3 and T4. The number of wait clock pulses can be 1, 2, or it can be anything depending upon the speed of 8086 processor and the peripherals. Either it may be for memory or IO device. During T1, the ALE signal will be 1. From T2 to T4, the ALE signal will be goes to 0. When ALE signal is 1, that is in during T1 time, the address and status lines on A19 to A16 will be placed the address information, that is A16 to A19. Once the ALE signal is goes to 0, that is from T2 to T4, this signal will hold the status information. However, this signal information is not required in the minimum mode. Similarly, for the address lines AD15 to AD0, during the T1 cycle, as ALE signal is 1, this address and data lines will hold the address information on the lines A0 to A15. From T2 to T4, the data, that is from D0 to D15, will be placed on the data bus. Once the data or the processor is ready for writing the data, so write signal will be active. When the write signal is active, then the data will be placed on the data bus. So in this case, the processor is sending the address information as well as the data information to the memory blocks or IO blocks. So as the bus in both the cases is in the same direction, so here we can't see any latency between address to data change as the processor is sending the data. So after write signal is deactivated, then the data can be changed on the address and data lines. When the valid data is present on the data bus, then DEN bar is going to be a 0. So this DEN bar will be reside in the 0 state till the data is present on the valid data bus. So in this case, the processor is, from the processor, the data is transferred to the memory or IO devices. So the data is transmitting or sending the data from the processor. So the dt by r bar will be at active 1 state, indicating it is data transmission for the bus direction from the processor to IO or memory blocks. The next one is maximum mode of 8086 and its timing diagrams. The 8086 microprocessor operated in maximum mode by strapping MN by MX bar pin to ground. In this maximum mode, IO read cycle, IO write cycle are the signals, that is IORC bar and IOWC bar are IO read and write commands. MRDC bar and MWTC bar are memory read and write commands. For both write commands, the advanced signals AIOWC bar and AMWTC bar are available only for maximum mode. They serve same purpose but are active 1 cycle earlier than the IO write cycle or IO command or memory write command. The timing diagrams are divided into 2 portions as read and write timing diagrams. The maximum mode 8086 processor is shown in figure 4. Here, The 8086 processor is operated in maximum mode by connecting MN by MX bar to ground signal. The clock generator is used for generating the necessary timing signals for the processor. The latches and data bus buffers which we have studied in the minimum mode, the same we are going to have for maximum mode. The main change we can see for generating of memory read and memory write, similarly IO read and IO write. So in the earlier minimum mode, we are used the signal M by IO bar, read bar and I write bar. Whereas in this maximum mode, the status signals S0, S1, S2, these three signals are used for indicating or for generating, either it is for memory read operation or memory write operation, or IO read operation or IO write operation. Next, the CS logic, this will be generated by using BHE bar and A0 for enabling the even address or odd address of RAM. Similarly, even address and odd address of ROM blocks apart from enabling IO devices. In this mode, the processor derives the status signals, that is S2 bar, S1 bar, S0 bar. The bus control derives the control signals using status information. The bus control has the input lines S2, S1, S0 bar and clock signal. The bus controller driver the outputs ALE, DEN bar, DT by R bar, MRDC bar, MWTC bar, advanced write command, read, IO read operation, IO write operation. Apart from that, advanced IO write commands. The address data and status data are similar to minimum mode. When ALE is equivalent to 1, these lines will provide the address information. When ALE signal is equivalent to 0, then these signals will provide the status information or data information. The status signals used and are available control and advanced command signals. The figure 5 shows the read cycle timing diagram for maximum mode of 8086 processor. So as it is maximum mode, process will be operated at the same speed. So we can see only 4 clock pulses, T1, T2, T3, T4. Usually 8 clock pulses will not be required for maximum mode. The ALE signal will be 1 for T1 cycle. From T2 to T4, the ALE signal is equivalent to 0. The status signals are active during T1 time, then it will be inactive till T4. The address and status lines, that is A16 to A19, are available when ALE is equivalent to 1, and the address lines when ALE is equivalent to 0, these will provide the status information. Similarly, AD15 to AD0 will provide the address information during T1. From T2 to T4, this will provide the data information. Once the data is ready, then it is going to generate the read cycle, memory read cycle. As the processor is reading the data direction is from memory or IO blocks to the processor. So in that case, the data is receiving, so the DT by R bar will be at 0 level. If you are placing DEN bar, this one should be active low, and if you are referring this one with the DEN, so whenever the data is present, this signal will be active here. The figure 6 shows the write cycle of maximum mode in 8086 processor system. Here, the number of clock pulses are required is T4. As we said earlier, as in minimum mode, we require wait clock pulses because IO device or memory may be slow response devices. Whereas in maximum mode, it is communication between processor to processor, so there is no need of any wait clock pulses. During T1, the ALE signal will be active, that is ALE will be 1. From T2 to T4, ALE signal will be 0. When ALE is active, then the S2 to S0 will have the active information, that is these signals are active, status information. From T2 to T4, these signals are not active. So what are the information which are having on S0 to S3 is not used here. The address lines from A19 to A16 will hold the address information when ALE signal will be 1. Remaining time, that is T2 to T4, this will hold the status information. The address lines AD0 to AD15 will hold the address information, that is A0 to A15 during T1. From T2 to T4, this will hold the data information, that is D0 to D15. Whereas in maximum mode, before a generation of a memory write cycle, in advance to this, one clock pulse, that is at a T2 time, the advanced write cycle will be active. Whereas the memory write command will be activated after one clock pulse. Similarly for IO write stage. The deactivation of advanced memory write command or IO write command will be takes place a little bit earlier than the normal memory write command and IO write command. The DT by R bar, so here the processor is doing the write operation, so the processor is sending the data, so the data is transmission, so this DT by R bar is going to be 1 during this time. That is at logic 0. As it is a DEN bar, this signal will be active during the data is valid on the data bus. Thank you all. So in this session, we have discussed the minimum mode and maximum mode, how to operate the 8086 processor in minimum mode and maximum mode. The various blocks are required for minimum mode and maximum mode are we are discussed. In minimum mode, we require a demultiplexer for generation of memory read and write signals. Similarly for IO read and write signals by using the signals in 8086 processor signals M by IO bar, read bar and write bar. Apart from that, we require latches for separating AD address lines and data information on the basis of ALE signal. The ALE signal will be 1 during T1 clock pulses. From T2 to T4, the ALE signal will be 0. The DT by R bar is for changing the direction of the data bus. So when DT by R bar is equivalent to 0, that means the data is received. So the processor is in receiving mode. So the direction of the data bus is input to the processor. When DT by R bar is equivalent to 1, it indicates the processor is transmitting some data. So whenever the processor wants to write the data to memory or IO devices, the DT by R bar will become 1. Similarly, in maximum mode, the various signals we are going to be generated by using the bus control unit. Apart from that, latches and a control signals generator is required for generation of various control signals. The status signals S0, S1, S2 are used for generating memory read or memory write operation. Similarly, IO read and IO write operation. In maximum mode, we have 2 additional control signals will be generated, 1 clock pulse earlier for both write with respect to memory and IO devices. Thank you all.
Like, share and subscribe. Hit the bell icon for more updates.